Student, let's continue our solution for question number 17 where we stopped. Question 17, part B. So according to the question, the enthalpy change for thermal decomposition of anhydrous magnesium carbonate was measured using enthalpy change for two reactions shown and applying Hess's law. The reaction 1 is given to us and the reaction 2 is also given. What they're asking is an experiment was carried out to measure the enthalpy change of reaction delta H for reaction 1. So they're basically talking about reaction 1. And 1.92 gram of magnesium oxide was added with the stirring to 40 centimeter cube dilute hydrochloric acid in an insulated container. The temperature was 30.8. So there's a rise in temperature. Okay, so now they are asking about calculate the delta AH for the reaction, including a sign and units in your answer. So you know the formula here we're going to use is Q is equals to MC delta T, and Q describes the relation between how much heat is absorbed or it is going to be released. And M is already given to us. What is the mass? The mass is obviously, because we are assuming the density is 1. So whatever is the volume is going to be considered as a mass. So we have placed it 40 here. This is 40, and then specific C is a specific heat constant. The value is given to us. We have to place it over here, and 30.8 degrees centigrade. This is the rise in the temperature. So delta T is this. So in this way, you're going to find out the value of Q. Basically, we are trying to find out the value of delta H. So in order to do that, we have this formula. For this formula, we have to first find out the value of delta of Q. So we have already calculated the value of Q, and N is the number of mole. N is the mole. And how are you going to find it? The moles of magnesium oxide. It's very simple. The mass is given. It's 1.92 here in the question. It is given over here. So we place by using the formula, moles is equals to weight in gram divided by mr. So we have placed the value of mr over here. So magnesium 24 and then 16 for oxygen, and then we have got the moles of magnesium oxide. And now placing it over here, so we have found the number of moles. Q we have already calculated. Now you're going to place it in the formula, and then you have got the value 108 kilojoules per mole. And because we already know that there's a rise in the temperature, so it's going to be negative sign. Now moving on to the next question is about Hess's law. It's not the next question, it's the same question but part 2 of that question. The enthalpy change of decomposition of magnesium carbonate can be found using a Hess cycle. Calculate the enthalpy change of decomposition by using a completed Hess cycle. Your answer to B1 and enthalpy change of reaction for reaction 2. So basically what they're asking is about for the reaction 2, they're asking the enthalpy change of reaction. So once they have already given to you, and then what you're going to do, you're going to place it Y for the reaction 2. And by completing this Hess's cycle, how you're going to do is that decomposition is happening, means breaking down of this magnesium carbonate into magnesium oxide and carbon dioxide. So by placing the value of reaction 2, let's see what's the reaction 2. This is the reaction 2, that is magnesium carbonate, HCl, MgCl2, H2O and CO2. So by placing the reactants MgCl2, H2O and CO2, MgCl, H2O and Cl2, as you can see the products are here. This is how you're going to place it, and the value is already given to us, that is 3.58 kilojoules per mole. Now how are you going to solve Hess's cycle? It's very simple. First you're going to see where the most of the arrows are generating from. That is going to be our starting point. So if you look at this cycle, this is the starting point. So all the arrows are starting from here, and where are they ending up? So that is going to be the final point. So this is the final point, right? And now what you're going to see, you're going to find two roots, the roots that are going to be starting from this point and ending on this final point. So here we got one root, this is root 1, and then we have got another root, this is root 2. Now what you're going to do is very simple. You're just going to balance these two roots, because you know that Hess cycle says either you're moving toward the product side from root 1 or from root 2, the answer or the energy change is going to be the same. So in this case, what you're going to do, first you're going to find out this value. Just give any value to it. Let's say I have given delta H1 and this is delta H2, and you have to find out the value, because we don't know this value, delta H. So what is going to happen, that magnesium chloride and water CO2 gives magnesium. Let's say, how are we going to place this? 3.58 is coming from where? This 3.58 is coming from here. That magnesium carbonate, when decomposed, react with hydrochloric acid, it gives you MgCl2, H2O and CO2. So if I compare this equation to this cycle, magnesium carbonate when reacts with HCl, so here it reacts, it will give this product, right? So what will be the delta H? Delta H is 3.58. Now coming back to the other delta H2, how are you going to find out what is delta H2? So it's simple. Delta H2 is the one that we have calculated. Remember, that is 108. This is delta H2. This. How are you going to find it out? That because they have asked you calculate the delta H for reaction 1. This was the reaction 1. That is HCl, magnesium oxide reacts with HCl, so gives you MgCl2 and water. So if you compare it, MgO and reacts with HCl to give MgCl2, carbon dioxide and water, right? So in this case, delta H is 108. Now we have got delta H, value of delta H1. We have got the value of delta H2. Now we're going to place it in this simple equation. Now you're going to compare these two roots. I have told you that how to find out the root, from the starting to the final product, from starting to the final product. Now what we have got, just place whatever delta H is coming in root 1. So there's only one delta H1. So you just place it over under root 1. And how many delta H are coming under the second root? So if you look at root number 2, this is root number 2. So we have got delta H and we have got delta H2. So we're going to place it. Then now it's very simple. You just place all the values that you have got. So after swapping the numbers, you got the value delta H, and that's kilojoules per mole. It's simple. Give a reason why it is not possible to measure the enthalpy change for decomposition directly. Obviously, because it's difficult to measure the temperature of solid in a powder form while it is being heated. It's easier to find in liquid form but difficult in a powder form. Okay, another question we have got here. The step involved in using magnesium carbonate ore in a process to capture carbon dioxide from the air is shown. Magnesium carbonate ore is heated in the furnace. The magnesium oxide produces, reacts with carbon dioxide over water. Okay, so basically they're not related. This information is actually not directly coming into the answer, but the main important part is to read this. Explains with reference to thermal stability of group 2 carbonate why the use of calcium carbonate rather than magnesium carbonate would increase the cost of the process. So they are telling you that calcium carbonate rather than magnesium. So calcium carbonate is expensive, and why is that? It is going to be related to thermal stability. So basically temperature, if you look at this diagram that I have made for you. So as you're going down the group, we're talking about group 2. So if you're going down the group, thermal stability is increasing. And why is that so? Because the size of the anion is also increasing. So here you can see the magnesium it's less stable as compared to calcium, which is more stable. Why? Because the charge is spread over in calcium anion, and that makes the carbon oxygen bond less weakened, right? So let's see how you're going to write it. Temperature required to decompose calcium carbonate is higher than that for magnesium carbonate, because thermal stability of group 2 carbonate increases down the group. As calcium ion is larger than magnesium ion, the surface charge density of calcium ion is less, or magnesium ion is more polarizing, so carbon oxygen bond is less weakened. So this is one of the reasons. Moving on to the next question. Explain why the condition for industrial production of methanol are at pressure 50 atmosphere and temperature 250. So it's very simple that you must have studied equilibrium chapter. It is related to that, because the forward reaction is exothermic. As you can see, it's negative. So lower temperature increases the yield of methanol, but because of this, what happened? This will lower the rate, so compromise the temperature is used. Here we are going to compromise on the temperature. As fewer moles of gas on the right hand side, so high pressure will move the equilibrium position to the right hand side, because here we are interested in producing more of the product, that is the methanol. So this is how you're going to solve this. This was it for your paper. Section C we have completed. Thank you so much for watching. If you have any comment or queries, please do comment.